Well, hello everybody. Thank you for taking the time to join today's webinar, which is all around the topic of LCA and PCF. The title of it is From Claims to Credibility, Why LCA and PCF Matter for Your Business. Don't worry about writing too many notes because a recorded version of the webinar will be available to you after the broadcast is finished. And this will include a recording of the Q&A session at the end. We'd love to hear from you, so please submit any questions at any time during the webinar, but reach out to us. You'll have our email addresses at the end, so please, feel free to contact us. No questions daft, just please reach out. There is a Q&A panel on your screen, and your questions won't be seen by anybody else within the group, but we will run through them at the end, so it will be anonymized to some extent. And we'll do as best we can to answer as many as we can today, but if you do run out of time, we'll definitely follow up with an email afterwards. Just a little bit about me. I'm Leon Youngs. I'm Head of Sustainability Services here at TÜV SÜD Northern Europe. Our region covers UK, Ireland, and the Nordic countries. And we provide all manner of carbon accounting services, all the way from corporate carbon footprint verification and product carbon footprint school validation, through to climate neutrality certification and carbon credit verification too. I'm an environmental biologist, and I started my career back in the 90s as an air quality scientist, where I basically spent my time climbing chimneys across the UK and taking samples of what was coming out of them to analyse the pollutants, basically for regulatory compliance checking for customers. I've also previously worked for the Environment Agency, where I helped them launch the emissions trading scheme back in the early 2000s, and I've had a number of roles here at TÜV SÜD, where I've worked for about 21 years now. And I've also previously looked after our MCS microgeneration certification scheme test certification business for small wind turbines. One of my current roles here is working as a technical advisor for DESNZ, the Department for Energy Security Net Zero, where I've been working for the last 4 years to try and help develop the metrology framework around the carbon capture, utilisation and storage business models. So still very much focused on CO2 and the biogenic CO2 element as well, to whatever's going to be captured potentially with these capture plants. But enough from me. If anybody wants to reach out to me after this and have a chat about any of the topics I've just mentioned there, then please do. But today we're focusing very much about life cycle assessments and product carbon footprints. And our presenters today are two very valued members of my team. We have Mohammed and Aish, who we'll get to know shortly. Now, Mohammed is a senior LCA professional. He's got broad sectoral knowledge and strong research background from Newcastle University, and he's got a phenomenal number of published papers to his name. He provides LCA PCF services, whether it's helping customers to actually do their LCAs, do the product carbon footprints, or we do the other side of it, where we actually look at the verification or critical review of people's LCAs or PCFs, more of that later. And he's also extremely adept with a number of the software tools that are out there on the market, things like SEMA Pro, OneClick, etc., etc. I also have Aish with me today, and Aish is a sustainability consultant with my team, and she's got a broad interest in all things sustainability. But she has got a soft spot for sustainable buildings, it has to be said. Aish has recently specialised as a carbon accounting auditor in my team, and she performs anything from corporate carbon footprint verification audits to things along the ISCC side of things. And we're currently looking at the CO2 performance ladder, as it's starting to grow in popularity for demonstrating supply chain sustainability as well. But without further ado, and that's enough from me, I'll put you in the capable hands of Mohammed and Aish.
Good morning, everyone, and welcome to our today's webinar, Why LCA and PCF Matter for Your Business. As Leon introduced me, I'm Aishwarya Shashi, working as Sustainability Consultant at TÜV SÜD UK. I will be one of the main speakers for the first half of the session today, and later my colleague Mohammed, who is a Senior LCA Consultant, will join me later to share his expertise and provide deeper insights on this topic today. So today we are covering following topics. We start with a brief introduction on environmental problems, then understand the concept of life cycle thinking. Then we focus on life cycle assessment and product carbon footprint and their importance. Then we also discuss about the LCA methodology and approach. We will also focus on the LCA critical review and PCF verification, and wrap up with related services we offer here at TÜV SÜD. Let's start with environmental problems. Thanks to the advancements in science and engineering and global awareness, we now better understand the scale of environmental problems and their far-reaching consequences for life on Earth. For instance, climate change led to rising sea levels, ocean acidification, increased wildfires, more extreme weather events like storms, heat waves, droughts, melting glaciers, and loss of polar habitats, shift in ecosystems, and species migration, and whatnot. The same applies to other environmental problems, which could lead to numerous devastating consequences for life on Earth. It is worth noting that many environmental problems are interconnected, and one can lead or intensify another. Tackling one can help address or, in some cases, intensify the other. Therefore, a holistic approach of environmental problems are needed. From holistic, we mean to consider different aspects. For example, environment, society, and economy. This is closely related to the concept of sustainability, which is based on the three pillars, environment, society, and economy. Here comes the life cycle sustainability assessment approach as a holistic approach. In fact, considering all the aspects related to the environmental problem is what actually helps true sustainability. Life cycle sustainability assessment consists of three approaches, as you can see on the slide, namely life cycle assessment to deal with environmental impacts, life cycle costing to deal with economic issues, and social life cycle assessment to deal with social and policy aspects. I'm not going to explain about all the life cycle sustainability approaches, but rather focus on life cycle assessment, which covers environmental impacts, as this is the main focus by emerging regulations, schemes, and standards. So today, rather than focusing on the technical aspects of the LCA or PCF, we are going to demonstrate the business relevance related to these aspects. Let us now understand life cycle thinking before diving into the concept of LCA. Life cycle thinking is the basis for the life cycle sustainability assessment approach. To explain life cycle thinking, we need to first explain linear or traditional thinking. Nearly all of the production system we have created today on Earth are usually based on the linear or traditional thinking, which is based on the notion that we need to keep feeding the system with input at one end to create an output at the another. However, the amount of materials or energy supplies is limited, as well as the environment resilience to waste or emissions generated. We have thought quite linearly about these aspects and has to be changed. We need a kind of thinking that goes beyond end-pipe solutions, for instance, pollution control, and focus on how to minimize environmental harm from the very beginning of the life cycle and across the life cycle of the products. Therefore, we need to adopt system thinking, which is about considering all the aspects of a system and interaction between its components. The sustainability application of that mindset to products, processes, or services is life cycle thinking, which is thinking about sustainability problems from a systems perspective. More specifically, life cycle thinking involves considering the entire life cycle of a product. That means the entire supply chain, and consider the unintended and intended consequences of different activities across the whole life cycle of a product. This is called as life cycle thinking. It also means considering the supply chain, stakeholders, and unintended consequences. For instance, reducing plastic might increase energy use somewhere else. This kind of mindset has established the foundation of life cycle sustainability assessment, including LCA, which is the main topic of today's presentation. LCA is the tool that operationalizes life cycle thinking. By first introducing life cycle thinking, I try to help you understand that LCA isn't just a tool. It's based on a broader way of thinking about how everything we produce impacts the environment at every stage of its life. Well, life cycle thinking also has more applications, for example, circular economy. Today, many companies want to move from a linear approach, which is a throwaway system, to a circular economy, which is a keep and reuse system. As you might know, circular economy is about reducing waste, pollution, saving money, and protecting the planet by efficient use of natural resources. However, it is important to design and assess circular economy in a way to avoid shifting burdens. System thinking is not only used in LCA, but it is one of the key aspects of circular economy concept. Circular economy cannot function without system thinking, because designing closed loops require considering entire value chain, stakeholders, and feedback effects. To make circular economy operational, you need to assess how products and services behave across their whole life cycle. Lifecycle thinking ensures that circular economy doesn't just shift the burdens, for instance, less waste but more energy use. LCA is one of the main tools used to test whether the circular solution is truly sustainable or not. So lifecycle thinking is how circular economy is implemented and measured. Now we will understand the concept of LCA and product carbon footprint, PCF. So far, we have discussed the foundation of LCA, which is the life cycle thinking. In fact, to achieve sustainability, we need to shift from linear to life cycle thinking. And to employ life cycle thinking and incorporate it effectively in our decisions, we need LCA. LCA acts like a facilitator or a tool to employ life cycle thinking and consequently achieve environmental sustainability by producing quantitative and tangible results. By definition, LCA is a standard method that helps assessing the environmental aspects and potential environmental impacts of systems. This is a common method to assess the environmental impacts for products or services and create scientific-based environmental claims. Simply speaking, using LCA, we take a look at environmental impacts of products within the whole life cycle of them. There are some typical stages in a life cycle of each product or service. It starts from the raw material extraction, next comes the production phase, next is the use phase, and lastly, the end of life, also called as grave. Sometimes we have some other stages like transportation, material refining, or purification, etc., which can be accommodated somewhere within the life cycle of a product. Overall, LCA adopts a cradle-to-grave approach. So there is also another version of LCA, which is very common, and that is product carbon footprint. I would like to highlight the key differences between these two. As we mentioned, LCA is a scientific-based and standard method. It has a substep, namely carbon footprint, which sometimes is interchangeable with LCA. Although there are great similarities, there are a few nuances. LCA is the overarching method that covers a product's life cycle from cradle to grave. According to ISO 14040 and ISO 14044, LCA is a tool for systematically analyzing the environmental performance of product or process over its entire life cycle. Its scope could be also partial, for instance, from cradle to gate. Carbon footprint follows the same methodology based on the ISO 14040-44 and can also cover the full or partial life cycles. However, then what's the main difference between these two? LCA covers a wide range of environmental impacts from global warming potential, acidification, ozone layer depletion to resource depletion, whereas the product carbon footprint mainly focuses on the global warming potential impact. For LCA, compliance is required according to the ISO 14040 and 44, whereas for the PCF, it is ISO 14067. Now, what are the main benefits of employing LCA? Well, there are many benefits with employing LCA, but most importantly, LCA helps evaluating environmental impacts in a quantitative way. The key in achieving a net zero economy is if you can't measure or estimate the environmental impacts in a credible way, you won't know what or where to reduce it. LCA helps to identify and prevent shifting of environmental burdens from one life cycle stage to another or between different products. LCA makes decision makers and stakeholders aware of the unintended consequences of their decisions, strategies, policies, etc. regarding a product or service or the strategies they follow, like net zero. However, while LCA is a powerful tool for highlighting potential environmental trade-offs, it does not inherently prevent burden shifting. The effectiveness of any LCA in avoiding such shifts depend on how its findings are interpreted and applied in decision-making processes. These are why LCA is useful for environmental sustainability assessment. But an important question is, what are the market drivers behind LCA? And why do companies need LCA? Well, there are many market drivers for LCA services, but what are the some market drivers that push the market to employ LCA? So regulation is one of the most important market drivers. There is growing regulatory interest in incorporating LCA. For example, EU battery regulation, the Eco-Design for Sustainable Products regulation, the Energy Performance of Buildings Directive, and so on. In the following slides, I will be going to explain how LCA supports the key industries in complying with these regulations. There is a transition in the new regulation from voluntary to mandatory environmental disclosures, which necessitates independent verification services. There are also some programs or schemes or standards that require environmental reporting through LCA, like Japan or South Korea carbon footprint programs, certification scheme like CORSIA, ISCC, and so on. Although some of the regulations, programs, or standards do not directly mandate LCA or PCF, some of their components may require companies to report their environmental performance through these techniques. Next comes the stakeholder pressure, business opportunities, and costs as the key drivers. From the viewpoint of business opportunities, apart from what mentioned over here, there are some income-generating opportunities if LCA is applied. For instance, the Carbon Border Adjustment Mechanism, CBAM, or selling credits on carbon markets, access to public and corporate procurement opportunities, as well as green finance, etc. LCA provide evidence and proofs to benefit from such schemes. So I can conclude that LCA is one study with multiple advantages. Now, I'm going to explain how LCA or PCF support key sectors such as construction, transport, manufacturing, fashion, electricity, and agriculture. I want to highlight a point that because global GHG estimates differ depending on the methodology and the year used, the numbers I'll show are indicative. They help us understand the scale and relative contributions of sectors, but a complete and up-to-date global picture isn't possible. The first key sector I'm picking up is the construction. Construction consumes 32% of global energy and contributes nearly 34% of global GHG emissions, according to the UNEP. Cement and steel alone contributes nearly 18% of global emissions, including both operational and embodied emissions. EU has come up with several regulations to reduce carbon footprint in the construction sector, such as the EU CBAM, where carbon reporting is mandatory for carbon-intensive imports by 2026. In construction, it's evident that it's from steel and cement. And next is the EPBD, which requires reporting life cycle global warming potential for new buildings over 1,000 square meters from 2028 and all the new buildings from 2030. Next is the EU Construction Products Regulation, the CPR, which mandates digital product passports along with the verified LCA or EPD data. And next, as we all know, BREEAM and LEED, which are almost popular certifications, they award credits for the whole building life cycle assessment and using EPDs. So as we know that now PCF is no longer optional, but it's an essential for survival. Next key sector is the transportation. Transport contributes approximately 14 to 15% of the global GHG emissions, with emissions rising faster than in many other end-use sectors. Regulations like EU battery regulation mandates EV and LMT batteries sold in the EU, and they have to disclose their full product carbon footprint. Failure to disclose simply means no market access. Next is the Corporate Sustainability Reporting Directive and the EU Taxonomy, which require mandatory Scope 3 emissions reporting, covering both upstream and value chain emissions. In the transport, the aviation alone contributes around 3.5% of global emissions. Hence, global regulations like CORSIA have come up with the strict measures like airlines must offset international flight emissions exceeding 2020 levels. And lastly is the Renewable Energy Directive, which is RED III, mandates a 29% minimum renewable energy share in transport by 2030. RED III requires LCA or PCF to verify GHG intensity reduction, sustainability compliance, and traceable emissions of transport fuels. Next is the manufacturing sector. So industry is the major contributor to the GHG emissions globally, with direct industrial emissions responsible for over 21% of the global total. The major contributors are iron, steel, cement, and chemical sectors, contributing nearly 71% of the total. Regulations like CBAM, as I have explained previously, puts a carbon price on the imports of high emission goods to prevent carbon leakage. The EU Industrial Emission Directive, the IED 2.0, is currently in effect at the EU level with full national implementation expected by mid-2026, sets stricter limits on air, water, and soil emissions from the manufacturing sites. It also requires the best available techniques and public reporting via Industrial Emissions Portal. So LCA or PCF is used by the manufacturers to choose low-impact materials, improve energy or resource efficiency in production, design products that last longer or easier to recycle. Next, we are going to discuss about the fashion industry. So nearly 2 to 10% of global GHG emissions comes from fashions and textiles. EU initiatives like the EU Strategy for Sustainable and Circular Textiles promotes transparency, durability, recyclability, and phases out fast fashion. Next is the eco-design for the Sustainable Products Regulation, ESPR, sets eco-design rules for carbon footprint disclosure, recyclability, durability, and so on. Next is the Extended Producer Responsibility, EPR, introduced from Waste Framework Directive. So it makes the producers held responsible for textile collection, sorting, recycling. That's the whole fashion supply chain by April 2028. Transition Pathway and Horizon Europe, they support circular innovation. The Green Claims Directive currently, which is suspended, as we all know that the claims must be substantiated under this directive. And PCF or the LCA are not mandatory yet, but increasingly vital for the credibility. And lastly, there is the possible EU CBAM expansion, which might include textile inputs like chemicals or polymers in the future. Next one is about the electricity sector. So electricity and heat generation accounts nearly 30% of all global GHG emissions. To calculate carbon costs for electricity and fuels, companies must use precise emission factors derived from an LCA or PCF as required under EU or UK emission trading system and CBAM. Under the RED III, renewable electricity, bioenergy, and hydrogen must meet GHG intensity thresholds calculated using LCA. Under the Green Claims Directive, any claim of low carbon or green energy must be backed by transparent, verifiable life cycle data. For instance, if a company says we use 100% renewable electricity via guarantees of origin, that claim is just not enough. It has to be backed with LCA-based carbon intensity values, not just the origin certificate. And lastly, the investors requires verified LCA or PCF data to ensure electricity projects qualify as low carbon. The last key sector for today is the agriculture. So nearly 22% of the global GHG emissions comes from agriculture, depending on the scope, land use, livestock, fertilizers, etc. The International Finance Corporation and the International Fertilizer Association supports eco-design and circular economy innovation in agri-inputs and fertilizer production and use. Certification schemes like CORSIA and regulation like RED III requires LCA for verifying GHG savings, traceability, and sustainability criteria for agricultural biomass, biofuels, and renewable inputs. Eco-labeling and carbon farming credits require PCF verification according to ISO 14067 for credibility and funding access. And lastly, the EU CBAM, as we all now know that from 2026, importers of fertilizers as well must purchase CBAM certificates based on the verified embedded emission. So now my colleague Mohammed will be going to deal with the LCA methodology and approach and other aspects of LCA. Thank you.
Thanks very much, Aish, and hello everyone. Thanks very much for joining this webinar. Before I move on to the next slide, I would like to add a few notes about the importance of LCA and product carbon footprint in today's business landscape. Today, more and more clients are asking their suppliers for verified product carbon footprint or LCA. And the reality is that not every company is ready to deliver such studies and reports. This can mean a real risk of losing contracts. A few years ago, life cycle assessment and product carbon footprint were usually done only for green products, flagship products, mainly to show a lower footprint or to justify the premium or high price. But that time has passed. Now the question many suppliers ask is much simpler. Do you have a carbon footprint or LCA for your product? And if the answer is no, in many business-to-business relationships, you might not even be considered as a supplier. Therefore, it's important to shift the mindset to stop viewing LCA and PCF as voluntary or nice to have exercises and start recognizing them as essential. For many business-to-business suppliers today, carbon data or LCA results have become as fundamental as price and delivery. Now let's talk about LCA methodology in more detail. As we discussed earlier, LCA is grounded in life cycle thinking and follows what we call a cradle to grave approach. That means it considers all stages of a product's life, from raw material extraction through manufacturing, transport, use, all the way to the end of life. It also includes the supply chains that provide materials and energy at each of these stages. To calculate the environmental impacts, LCA looks at what goes into and comes out of each stage. For example, the resource and energy as inputs and emissions, waste, products and co-products as outputs. You can think of each stage as a kind of black box. We don't necessarily need to know every technical detail inside the box, such as chemical reactions or machine operations. We mainly focus on inputs and outputs. That said, understanding what happens inside the box can still be valuable. It helps verifying data quality, improve assumptions, and identify inefficiencies, specifically when primary data are missing and we rely on generic database or assumptions. This deeper understanding can make the results more robust and credible. Another important aspect of LCA is that it can account for regional differences across the supply chain. In reality, each stage of a product's life cycle and even sub-processes and sub-stages within those stages often take place in different parts of the world. For example, raw materials may come from one region, manufacturing may happen in another, and assembly, use, end of life may happen in some other regions. Each of these regions can have very different energy system, transport methods, local supply chains. Therefore, these variations can significantly influence the overall environmental impact of the product. LCA helps capture these geographical differences. It allows us to reflect the fact that producing a component in one country might lead to higher or lower emissions than producing it elsewhere, depending on factors like energy mix, electricity mix, transportation distances, transportation methods, and so on. So in short, LCA not only looks at the product's life cycle, but also recognizes that the global nature of supply chain plays a major role in the footprint of a product. Let's now look at, in more detail, at LCA methodology. As mentioned earlier, life cycle assessment follows ISO 14040 and 14040 standards. According to these standards, every LCA study must go through 4 mandatory steps: goal and scope definition, inventory analysis, impact assessment, and interpretation. The first step is goal and scope definition, which sets the direction for the whole study. Here we define what we want to achieve, or what product system is being studied, what's the functional unit, what's the system boundaries for the assessment. The second step is the lifecycle inventory analysis, where we collect data on all inputs and outputs within those boundaries, for example, materials, energy, emissions, waste, etc. It's a bit like an accounting exercise. Important to note here is that the quality of data determines the reliability of the results that we get from LCA. For example, poor or outdated data can easily lead to misleading conclusions. Apart from that, a transparent inventory allows others to reproduce or review our work. The third step in a lifecycle assessment is lifecycle impact assessment, or LCIA. Here we classify and characterize the inventory data to calculate potential environmental impacts, such as climate change, acidification, eutrophication, etc. While it's possible to do this manually, in practice, most studies rely on software packages, which make the life easier by automating the calculations, providing and generating graphs, impact results, and charts. Finally, the fourth step is interpretation. In this stage, we analyze how much each life cycle stage or process contributes to the overall impact. This is often called a contribution analysis. We also identify hotspots, perform checks for completeness, consistency, we perform sensitivity analysis, and finally, we draw conclusions and make recommendations for improvement. Lifecycle assessment is a step-by-step process, as we have seen in the last slide, but it's not always a straight line from start to finish. As you collect data or uncover new information, you might need to go back and revisit earlier stages. For example, you might realize that your initial goal needs to be adjusted, or the system boundaries should be expanded, or there are some data gaps that need to be filled. This back and forth process is called iteration. It's a normal and essential part of doing a robust LCA, ensuring that your final LCA results are accurate, consistent, and meaningful. In simple terms, you can think of LCA as a road trip with a flexible plan. As you move along your route, you collect data, you analyze your results, you might discover new information that changes your understanding of the journey. Maybe your destination, meaning your goal, needs adjustment or to be refined, or the route you planned, which is your scope, needs adjustment. When that happens, you don't start over. You simply revisit the earlier steps to make sure everything still aligns with your updated direction. This iterative process helps keep the study consistent and builds the confidence in the results. Let's briefly take a look at some of the main software tools used for lifecycle assessment. There are many options available, and the choice really depends on the goal of the study, the sector, and the level of expertise required. Most of these tools combine process modeling with lifecycle inventory databases and follow ISO 14040 and 14044 framework for calculating environmental impacts. Some of these software packages and platforms are shown on the screen, for example, CIMA-Pro, OpenLCA, etc., etc. Each has its own focus area. For example, some of these software packages are more suited to industrial applications, others to building or transport, and some are open source and used mainly in research. The key message here is that the software is just a tool. The quality of LCA is ultimately depends on the data, assumptions, and transparency behind the model, not necessarily on which software package you use. To support the inventory stage of an LCA, in which we need data, the second step of lifecycle assessment, which is called LCI or lifecycle inventory analysis, we rely on lifecycle inventory or LCI databases. These databases provide average data on supply chains, from electricity generation and raw material extraction to transport, manufacturing, and recycling. They are often built into or compatible with LCA software tools, giving quick access to reliable background information. Examples are, for example, EcoInvent, AgriFootprint, Gabi, etc. The choice between databases usually depends on the sector, the region covered, and the type of data available. For example, some focus on agriculture, some others on energy or manufacturing. There are some databases that covers a wide range of sectors. However, this is not the whole story. These databases provide useful averages, but they do not replace high-quality primary data collected from your own operations. Reliable LCAs always combine both sources, to get accurate and credible results. So far, we have discussed what LCA is, why it's important, how it's conducted, from standards, methodology, to data and tools. But conducting an LCA is only one part of the journey. It provides a valuable framework for understanding environmental impacts, generating useful data, delivering insight that help improve products and services and inform decision making. However, the credibility of those results depends on what happens next. Without independent review or verification, the findings may not be fully trusted, especially when they are in public claims, regulatory submissions, or business decisions. Independent verification brings reliability, transparency, and assurance. It shows that the study has been checked by a qualified independent third party, that the methods and data make sense, and the conclusion can be trusted. In other words, an LCA without review is like a puzzle, missing a key piece. It might look complete, but it lacks the element that gives confidence in the whole picture. But why it is important in the market? The growing focus on environmental sustainability has created strong competition among companies, each eager to position itself as the most sustainable or greenest player in the market. But this race also comes with a risk, which is a greenwashing, and that is when organizations exaggerate or misrepresent the environmental benefits of their products or services to appear more sustainable than they actually are. There's a risk, as we mentioned, and this risk increases when companies make sustainability claims without proper scientific backing or independent verification. That's why technically and independently substantiated claims are so important. On the other hand, reporting environmental claims is becoming much more regulated, and substantiating those claims is now essential. So as new regulations emerge, this kind of substantiation is becoming not just the best practice, but in many cases, a legal requirement to prevent greenwashing and ensure transparency. In EU, for example, we already see several regulations that either require or recommend environmental impact assessment and verification. For example, EU battery regulation, circular economy action plan, etc. Each of these either defines how environmental claims should be reported or mandates some level of verification. And this trend is not limited to Europe. Similar initiatives are emerging globally from UK, US to China and Canada. The key message here is that regulators are increasingly focused on verified claims because only verified changes are tangible, trustworthy, and effective. Therefore, like any other environmental claims, LCA and PCF results must be substantiated. Now we have seen environmental claims are becoming more regulated and verification is essential. Let's look at how TÜV SÜD supports this through our LCA and PCF services. These services help companies to quantify, verify, and communicate their environmental performance in line with the latest regulatory expectations. Accordingly, and in line with market needs, TÜV SÜD, as an independent party, has developed a range of services for LCA and PCF to help organizations to substantiate their environmental claims. But before explaining these services, it's important to clarify the distinction between these three types of assessments that you can see on the slide. On the left-hand side box and the right-hand side box, if you look at the bottom, you can see some terminology that we use: critical review on the left-hand side and validation, verification on the right-hand side. A critical review is an expert evaluation of an environmental claim, similar to gap analysis or mark verification. It's conducted to check reliability and completeness of a study. The next is verification. That is a retrospective assessment, verifying that environmental data and claims are accurate based on historical results. Validation, on the other hand, is prospective. It assesses whether projected or estimated data are plausible for future scenarios. Basically, the depth and level of assurance is higher during a verification or validation, while a critical review of LCA or PCF is more focusing on the right application of the methodology and to be prepared for the actual verification or validation. Nevertheless, each of these assessments has its own importance and application. Now, regarding the services themselves, TÜV SÜD delivers lifecycle assessment based on ISO 14040 and 44, and also product carbon footprint based on ISO 14067. For LCA, we can either conduct LCA, conduct a complete LCA study, or provide a critical review of an existing study carried out internally or by another consultancy. When conducting an LCA, we will provide a report, a model. When providing a critical review, we issue a review report and critical review statement confirming compliance with the relevant ISO standards. For PCF, we offer similar services. We conduct PCF, we perform critical review. Additionally, we offer product carbon footprint verification and validation, which are particularly important for regulatory compliance for example, under UAT regulation or CBAM. When verification or validation is performed, we provide a list of findings along with a verification or validation statement. On-site audits are mandatory for PCF verification or validation, unlike LCA critical review, which does not necessarily need site visits. In summary, TÜV SÜD provides end-to-end support from LCA and PCF modeling to review, verification, and validation, ensuring that environmental claims are credible, transparent, and aligned with international standards. These services play a vital role in strengthening sustainability efforts and ensuring credibility behind environmental claims. With so many claims in the market, independent verification based on ISO standards is essential to build trust and value. Through LCA critical review and PCF verification, companies can demonstrate that their sustainability statements are transparent, accurate, and aligned with regulations and stakeholder expectations. They also provide credibility, reducing the risk of greenwashing by ensuring that all data is objectively assessed by third parties. Importantly, these verifications promote environmental transparency while protecting intellectual property, which is really important, and allows companies to share results confidently without revealing sensitive details. Beyond compliance, these services drive business differentiation, market access, and stakeholder confidence, positioning companies as leaders in credible and verifiable sustainability performance. At TÜV SÜD, we bring together strong industry knowledge, LCA expertise, and highly qualified professionals to deliver robust lifecycle assessment and product carbon footprint. Our industry expertise spans sectors such as consumer products, electronics, automotive, chemicals, polymers, etc., etc. This breadth allows us to address sector-specific data challenges and ensure our assessments are both technically sound and practical. We have deep LCA expertise working with all major tools, databases. This flexibility lets us align with client systems or recommend the most suitable solutions. Finally, we have a pool of qualified reviewers and verifiers with strong LCA knowledge and carbon accounting backgrounds, supported by ongoing trainings. This ensures every reviewer meets the international standards requirements with consistency and credibility worldwide. At TÜV SÜD, Green Energy and Sustainability in Northern Europe, we have core services areas, sustainability, hydrogen, carbon capture, usage and storage, and wind. In sustainability, we help companies manage their carbon accounting, from footprint calculation and verification to lifecycle assessment and product-specific footprint validation. For hydrogen, our services span the full value chain, from electrolyzer and refueling station certification to fuel cell testing and certification. In CCUS, We support clients with regulatory and monitoring advisory, CO2 flow testing in different phases, and measurement consultation, including uncertainty analysis and R&D flow assessment. Finally, in Wind, we provide lifecycle services from site assessment and technical due diligence to project certification, in-service inspections, and life support such as repowering and lifetime extension. And that brings us to the end of today's session. We have covered the essentials of lifecycle assessment, its foundation, importance, methodological steps, role of independent review and verification in ensuring credible and transparent results. We also discussed product carbon footprint, how its scope compares to full LCA. In addition, we explored how TÜV SÜD supports organizations through our expertise and service portfolios, particularly through our LCA and PCF services. And now we would be happy to take your questions. And of course, if you would like to discuss any of these topics or services in more detail, or if you need any help with setting up a system for collecting data, performing LCA or PCF, feel free to reach out to the team, myself, Leon, or Aish, and we can talk offline as well. Thank you very much.
That's smashing. Thank you very much to both Aish and Mohammed for that. I hope you've all found that interesting. There was enough detail in there to spark some questions as well. So I will summarize what we have. One of the main questions here, and I think it's probably something that everybody struggles with, is the data gathering. So I think it's more a statement than a question, but basically saying that data gathering is the most difficult part. And I think, as you've touched on there, Mohammed, around the preference being for primary data to give you the best level of assurance when it comes to looking at your claims, your environmental claims, is obviously the best bet, but it's not always possible. And one of the attendees, I think they mentioned that their product has basically got 1,500 lines, separate pieces which make up this final product. So it's how you would approach something as complex and as technical as a product which is made up of 1,500 separate components potentially.
Yeah. That's a good question, and actually,
it's a vehicle, if it helps.
I can imagine, because it usually happens in large OEMs and vehicle manufacturing companies. Well, as I said, the best is to provide, prepare, collect primary data for the operation. You can start with your own operation, but we appreciate that it's not always possible. So the best practice is to start gathering data and understand where are the hotspots, where are the problems, where are the data gaps, and then try to select or choose a strategy or define a strategy to come up with primary data. If it's not possible to come up with primary data for your operation, your own operation, that would be a problem, definitely, because your own operation means that you have the control over the consumption of different inputs and outputs. But for the operations that they are outside your immediate operation, for example, if you receive a battery from China and you don't know how the cathode is produced, then you are reliant on the supplier to provide you with primary data. In these cases, you can discuss with the supplier, and you can sometimes companies can pressure the suppliers because you are a stakeholder, you are a customer, so you can ask them to provide you with such data. If that's not possible, you can start using some databases like Equinvent or Gavi, and then see how the database could fit your operation, but always consider the data quality. But my message is that doing something is better than doing nothing. Some companies just stop, some companies just use random numbers, but the main thing is to conduct an LCA, start with screening, and then you improve the quality, but always make things transparent and record things. Hope it answers the question.
I think the big challenge is with the supply chain, isn't it? And that's trying to get decent data from your supply chain is always going to be a challenge, and everybody's still in that same, for all walks of life, all industry sectors, everybody's in that same position at the minute. And as Mohammed says, you've just got to do the best you can with what we've got available at the minute. Things such as the EU battery regs coming in, which mean that individual batteries are going to have a passport, where you'll have a product carbon footprint associated with that battery. So there are things in place, or beginning to become in place, which are potentially going to help with your supply chain challenges. One question I've got as well is around databases and which ones are best suited for specific sectors. So one specific question is about the automotive sector. Which database is potentially the best for car industry?
Well, my technical and personal opinion is that it depends on the sector. So when you're saying automotive sector, I would say maybe you should choose a database that covers most of the processes, and Ecoinvent could be one of them. But if you want to be aligned with EU battery regulation, you might also need to use some other databases like the European Union database that is still under development. So yeah, so as I said, it depends on the sector. For vehicle manufacturing, Ecoinvent could be one of the good sources.
And an interesting one here as well around the actual reliability of some of these databases. So somebody's asking as well, are these databases verified? And how can you trust these databases? Things like OpenLCA, Ecoinvent.
Mm-hmm. That's actually a really good question. And there are some discussions around this topic in academia and in industry. Companies like Ecoinvent and One-Click LCA, as far as I know, they have data collection and quality assessment procedure. They check data, record data quality. Also, they regularly they check the validity of the data and update the database. But it doesn't mean that we can say, for example, Ecoinvent, One-Click LCA is trustable or not. So it depends on the lifecycle inventory dataset that you are using. For example, I remember the time I was working for Newcastle University. I was looking for an LCI for UK electricity or GB electricity, and the dataset in Ecoinvent at that time was very old. For the year 2021, the available data set was for 2014. So I had to update this myself. So it depends on the inventories that you are choosing. But there is, as I said, a quality assessment procedure with some of these databases.
And I think it probably highlights the rationale, what we're arguing for here, which is for us to provide that independent third-party assessment so we can make sure that the data and the data sources stand up to scrutiny as well. And that's primarily what our role is in all of this.
Exactly. And a big challenge, based on my experience, is when companies use PCF or LCA from their suppliers, and then we need to invest more time to scrutinize the quality of those PCF and LCA, if they're verified, if there's a critical review with them. In some cases, there's none. And then we need to invest time to check those reports if there's any available.
Right, this is one of the questions that always comes up. What's the difference between PCF validation and PCF verification? I know you touched on it during the presentation there, but if you could just explain that subtle difference.
Yeah, Aish, do you want to answer this question? Because I want to also engage.
I can take. So, yep, the PCF verification and validation is that PCF verification is the history. So if you already have the data available to calculate the product carbon footprint, then you're good to go for the verification. But validation is something you have to estimate for the future. So something you validate for the future. So that's the main difference between these two. And yep, if you want to add on something to it, Mohammed.
Yeah, I think that's all we can say about verification.
It's about direction of focus, isn't it? So verification is backward looking, validation's forward looking. That's it essentially.
Yeah.
So somebody here has got GHG data at a corporate level. So it's an organizational GHG data. Can they use that data for their PCF
Okay, so I can take this question. So the problem is the GHG follows the ISO 14064-1 and the PCF follows 14067. So it's a different path because product carbon footprint is mainly based on the LCA standards as well, ISO 14040 and ISO 44, but for the GHG, it's ISO 14064-1, which is not entirely based on the life cycle assessment. So it's two different approaches. Maybe a part of the data inputs can be used, but not the complete organization level, since the two approaches are different.
Yeah, I think the data gathering, some of the data gathering you've done for your corporate footprint may be transplantable into your PCF, but it's not an easy kind of
and also
it's not easy maths to do, is it?
Yeah, and also that highlights a challenge in the market at the moment. Companies, for example, do ESG reporting, corporate carbon footprint reporting, but the data and the approaches are in silos. Companies should take a look at these data and see how they can be connected and can be used. For example, some of the ESG data might be able to be used for the carbon footprint. So they should be able to use some of the data from other sustainability reporting. And there should be some systematic way within an organization to link the available data from other sustainability reporting to the one that you are working on.
Yeah, and just to finish on that sort of corporate carbon footprint approach, there's a question there around, can spend-based methods be used for embodied emissions?
Yeah, go ahead, Aish.
Yep. So if the product level EPD data are not available for carbon footprint, then definitely they can use the monetary-based emission factors. So we have many databases for that available, like extended environmental input-output database and other spend-based factors, which can be used for spend-based emission. But of course, this is not the most accurate way, but something is better than nothing, as Mohammed said already. So, yep, it is possible to calculate using spend-based.
Yeah, I'm conscious of time. We've still got quite a few questions to get through, so I might just get through another one or two before I do my wrap-up. There's people asking about average costings. Again, I think that's a discussion I think we'd have to have with you person to person, I think, because everybody's situation is different, and different complexities as well of what your life cycle assessment is and what your boundaries are you cradle to gate, are you cradle to grave, etc., etc. So I don't think we can really talk about costings at this stage until we've had a conversation, I think, one-to-one. Right, so the last one I'm going to touch upon, which is quite an interesting one, is why spend such a lot of time developing a life cycle assessment for a product, especially for a vehicle, for example, when the majority of the emissions are going to be the lifetime of the actual machine itself, you know?
Yeah,
it comes back to the rationale for undertaking an LCA in the first place, doesn't it? And we talked about the drivers earlier on for why people need to get these done, and that's more of a kind of higher level ethical question, I think, isn't it? Around, you know, there might be more emissions from the machine in its lifetime as opposed to the actual embedded emissions in building the thing in the first place.
Yeah, so that question is around what is the business case for performing LCA or PCF. So there are many things. The first thing is that at the moment it might be voluntary, but in the near future might become mandatory for car manufacturers to report the LCA or PCF for their cars to meet the requirements. But there are other things, there are other benefits of performing LCA. So if you think that the majority of emissions lies in use phase, that's good for you. So you can report the emissions, and also when you perform LCA, you can mention that the car manufacturer contribution is not that much. So it's really good for car manufacturing companies if their contribution is not that much compared to the use phase.
Lifetime emissions.
Also,
I think I'm going to have to wrap up shortly, Mohammed. So sorry to cut you off. We can reply in detail, I think, to a lot of these questions, person to person, if that's okay.
Yeah, no problem. Yeah. Go ahead.
Right. Well, apologies for pushing you right up to the end of the session, but thanks again for joining us today. I hope you found it informative. As we said earlier, we'll be sending out this on-demand version of the webinar after the event is finished. There'll be in our resourcing section of the webpage. For attending today, you do get a 10% discount code, webinar_10, for any TÜV SÜD Academy training courses that are available online. And also keep your eyes open, because we do a lot of these webinars on different sustainability related topics, things that are pressing. And we also ask you if you have any topics that you'd want us to cover in more detail, then we'd be more than happy to do that. Go through a worked example of an LCA, for example, something like that. So if you've got any ideas that you'd like us to present in the future, then please reach out. And details are there. Please get in touch if you need to. And thank you once again to the two presenters, Aisha and Mohammed, who've been great today. And thank you all very much for your time. I appreciate how precious an hour is of your day today. So I appreciate that. And we look forward to hear from you in the future. Okay, so thank you.
Thank you, everyone.